Listen, electrolysis. Electrolysis means what, ma? Electrolysis means, just a minute. Electrolysis. What is electrolysis definition? Electrolysis means it is the process. It is the process of. It is the process of decomposition. It is the process of decomposition of electrolyte. Decomposition of electrolyte by passing current. By passing current is known as electrolysis. Okay, electrolysis means the decomposition of electrolytes. Already last class we have discussed about electrolytes. Strong electrolytes are present as well as weak electrolytes also be present. Okay, so the process of decomposition of electrolyte by passing electricity or passing current is known as electrolysis. So where the device which used for electrolysis, the device which used for electrolysis known as electrolytic cell, known as electrolytic cell. So the electrolysis process is mainly taking place in electrolytic cell. See, construction of electrolytic cell means we need to take one U-shaped tube. Okay, so in that U-shaped tube we have to take two electrodes. The two electrodes, cathode and anode. These two electrodes are connected with battery. These two electrodes are connected with a battery. So this is the battery symbol, positive charge and negative charge. This negative end of the battery is connected with cathode. This is known as cathode. Cathode is negative electrode. Negative electrode. Okay, and the positive end of battery is connected with the anode. So the anode is positive electrode. So the electrolysis process here, what is the taking place? Electrolysis process means it is the important application. What type of chemical reaction is going on? Redox reactions are going on. So we need to take suitable electrolyte. So electrolyte is nothing but one solution. Thus the solution solute must should be ionized. For example, urea in water is a non-electrolyte. So any NaCl in water that acts as an electrolyte, strong electrolyte. So this is the solution is known as electrolyte. Okay. So anode is positive electrode and cathode is negative electrode. See, the battery we are using external source battery, then we are passing electricity. Electrons are passing. So the electrons are entered from cathode and migrated towards and they're leaving from anode side. Means into the from externally the electrons are external electrons are moving from anode to cathode. Anode to cathode. Okay, but internally electrons are moving from anode to cathode side. Means from anode oxidation takes place, that electrons are goes to cathode and cathode reduction takes place. So in external circuit, the electrons are enters from cathode and leaving from anode from the electrolyte. See, this is the diagram or this equipment is known as electrolytic cell. This equipment is known as a electrolytic cell. So this electrolytic cell, what happens now? In electrolytic cell, we are using electric current. Means electric current. Electrical energy is converted into chemical energy. Electrical energy converts into chemical energy. So here electrical energy is converted into chemical energy. That chemical energy useful to decomposition of electrolyte. Okay, here two electrodes are present. What is the use of electrodes? Electrodes are useful for medium transfer of electrons. Means they are used acts as a medium for entering electrons or transferring of electrons as well as leaving of electrons. So here in electrolytic cell, two electrodes are present. They used for acts as they're used for transfer of electrons and leaving of electrons from electrolyte. So the electrodes are useful for the entering of electrons into the electrolyte as well as leaving of electrons from the electrolyte. So that medium. So for that medium, electrodes are useful. So what are the electrodes are present? Two types of electrodes are present. So those are cathode. The second one is anode. So what is cathode? Cathode is connected with the negative end of the battery. Cathode, it is connected with negative end of battery through which electrons enters into the electrolyte. So through which electrons are enters into the electrolyte. So how that electrons are current enters into the electrolyte? Through which anode, through which cathode side, So cathode is nothing but the cathode is a negative electrode. It is a negative electrode. It is connected with the negative end of the battery through which electrons are enters into the electrolyte. At cathode, oxide reduction takes place. At cathode or negative electrode, reduction takes place. Reduction takes place by positive ions. Because the electrolyte forms positive and negative ions. Positive ions goes to cathode and negative ions goes to anode. Because oppositely charged ions goes to respect to their electrodes. Opposite charged electrodes. Okay. So reduction takes by positive ions. So at cathode reduction takes place. Now at anode, what is anode? Anode is nothing but what? Anode is positive electrode. Positive electrode. It is connected to the positive end of battery. Positive end of battery, through which electrons leaving from the electrolyte, through which electrons are leaving from the electrolyte. And at anode oxidation takes place. At anode oxidation takes place. Anode oxidation takes place. So this is the mechanism is taking place in electrolytic cell. Okay, let's see. For example, take Ma electrolyte. Take Ma electrolyte. Ma aqueous solution acts as electrolyte. Then it undergoes electrolysis. Means ionization takes place. First, initially ionization takes place. The electrolyte, first ionization takes place. So how it will be ionized? By passing electric current from the external source by the battery from cathode side to anode side. Means the current is entering from cathode side and leaving from anode. Then immediately the electrolyte will be ionized to form positive and negative ions. The electrolyte ionizes to form positive and negative ions. The positive ions means cations. The negative ions are called anions. The positive ions moves towards cathode side and negative ions moves towards anode side. At anode, what happens now? Oxidation takes place. Oxidation takes place means the negative ion converted into atoms. Means A minus converted into A by loss of electrons. What is oxidation? Increasing the oxidation number. A minus means its oxidation number is -1. A for atoms oxidation state is 0. That's why -1 is converted to 0 means oxidation number is increased. It is oxidation of reaction. Or at anode, oxidation takes place by the releasing of electrons. Then that electrons are moved towards at cathode. The electrons are moved towards at cathode. What is cathode? At cathode, positive ions are present. Then they accept the electrons converted into M. Okay, by the reduction, because a +1 is converted to 0. Means oxidation number decreases. That's what is called reduction. It is called a reduction. So in electrolytic cell, both oxidation and reduction takes place. That's why the electrolysis process is redox process. The electrolysis process is a redox process or redox reactions. See, at anode, the negative ions undergoes oxidation to form molecules or neutral molecules. Okay, and cathode also positive ions undergoes reduction to give they produce some products. Then what happens now? Their electrolyte converted into individual molecules or individual compounds. Electrolyte, whatever the electrolyte we are using, it ionizes it to gives different products. They forms different products at anode and cathode by undergoes oxidation and reduction. So for this for these reactions, oxidation and reduction reactions, externally requires some energy. That energy is nothing but what energy it is utilizing? Electrical energy it is utilizing. That electrical energy is converted into chemical energy. That's why this cell is called electrolytic cells. This equipment totally is known as electrolytic cell. It is known as a electrolytic cell. For example, if the electrolyte, so here it is very important one for JEE and NEET examination, especially as well as for CET examination. If the electrolyte contains two or more than two positive and negative ions present. So two positive ions or two negative ions are present. Then what happens when the two positive ions goes to cathode and two negative ions goes to anode? Then which we need to first decompose, means which we need to first undergoes reduction as well as undergoes oxidation, then computation will come. So it depends on their discharge potential value. Okay, so more than two or more than two positive and negative ions are present. Then which ions has low discharge potential values? Low discharge potential values. It can be deposit. First. So the discharge potential values are inversely proportional to deposition order. So for example, discharge potential values for cations as well as anions different. So let's see discharge potential values. Order. For anions discharge potential value. So which having more discharge potential value, its deposition is very less. The deposition order is very less. Which having very low discharge potential value, it can be deposited very easily respect to their electrodes. So that point is very important. See different types of anions, the discharge potential values. F minus, SO4 2 minus, NO3 minus, OH minus, and then Cl minus, Br minus, I minus, and then CO3 2 minus. So which having very low discharge potential value, CO3 2 minus has low discharge potential value. Okay, so these different anions, they discharge potential values now. Let's see cations. Cations discharge potential values. Lithium plus have more discharge potential than potassium ions, then sodium, and then calcium, and then Mg plus 2, and then Al3 plus, and then Mn plus 2, and then zinc Zn plus 2, chromium 3 plus, and iron plus 2, and then H plus, then copper plus 2, and then mercury Hg plus, and then silver plus, and then platinum plus 2, and then gold plus 3. These are the discharge potential values of different cations. See deposition order of first one anions. If discharge potential values are more, then the deposition order will be very less. The deposition of respect to negative ions or positive ions are very less. So CO3 2 minus can be deposited very fast when compared with iron minus, when compared with Br minus, when compared with Cl minus. For example, in electrolytic cell, they contain OH minus ions and Cl minus ions. Both are present at anode. Then the Cl minus ions can be deposited very fast. Then it can undergo oxidation, liberate Cl2 gas when compared with the OH minus ions. When compared with the OH minus ions. Let's see anions. F minus, SO4 2 minus, and then NO3 minus, and then OH minus, and then Cl minus, and then Br minus, and then I minus, and then CO3 2 minus. And the deposition order for cations. Cations means reverse. Li plus has more discharge potential. That's why it cannot deposit very easily when compared with K plus, when compared with Na plus, when compared with Ca plus 2, when compared with Mg plus 2, when compared with L plus 3, when compared with Mn plus 2, when compared with Zn plus 2, when compared with Cr plus 3, compared with Fe plus 2, compared with H plus, then copper plus 2, and then Hg plus, and then Ag plus silver salts, and then platinum salts, and then gold salts. So that is the deposition order of different cations. Okay, is very very important for JEE and the NEET. Listen, students. For example, during this electrolysis process, the electrolyte contains 2 or more than 2 positive and negative ions are present. So, respective electrodes means an anode and cathode, which can be deposited very easily. It depends on their discharge potential values, which cations or anions having lower discharge potential value, it can be deposited very easily. For example, compared to OH minus and Cl minus can be deposited very easily. Compared to H plus ions, see here, compared to H plus ions and copper plus 2 ions, both are present in the electrolytic cell. Then copper 2 plus ions can be easily reduced, can be deposited into the form of copper when compared to H plus ions. Or H plus ions and Al3 plus ions are present in the electrolytic cell, then Al plus 3 ions cannot be deposited, cannot be reduced very easily. Then H plus ions can be reduced very easily, converted into H2 gas When compared with H plus and silver plus ions, the silver plus ions can be easily reduced and deposited in the form of silver at respect to cathode when compared to H plus ions. So that is the very important points now. Okay, let's see for example. Okay, observe once again. It is very important. For NEET and JEE, direct questions they are asking from this concept only. Okay, let's see. For example, aqueous NaCl on electrolysis. Aqueous NaCl, sodium chloride acts as an electrolyte. Aqueous NaCl acts as electrolyte. Okay, then at the anode, what is the product formed at anode and the cathode? What is the product formed at anode and cathode? At anode, chlorine gas will emit, at cathode, hydrogen gas will form. These are the products formed at anode and cathode. But NaCl is present. What about Na plus ions? That Na plus ions, compare that Na plus ions and H plus ions. H plus ions discharge potential is very less when compared with Na plus ions. That's why H plus ions can be reduced very easily. For example, see NaCl on electrolysis produce Na plus Cl minus ions, and water also to produce ionize to produce H plus and OH minus ions. See, among that two ions. See here, two positive ions are present and two negative ions are present. Then deposition order or discharge potential order. Discharge potential order. For anions, OH minus ions is more than Cl minus. That's why Cl minus can be deposited very fast when compared with the OH minus ions. For cations, Na plus is more than H plus. So deposition order. Deposition order OH minus ion less than Cl minus. The second one is Na plus less than H plus. This is the deposition order. So that's why what happens in that electrolysis process, the electrolysis of NaCl, aqueous NaCl, for aqueous NaCl especially. Then what happens at anode oxidation will take place. So which will be oxidized when compared with OH minus and Cl minus? Then Cl minus can be oxidized, Cl minus, to produce Cl2 gas and forms 2 electrons. At cathode, what happens? Reduction reaction takes place, which will be reduced very easily. Compared to Na plus and H plus ions will be reduced very easily. Then 2H plus, it accepts 2 electrons, produce hydrogen gas. So what are the rest of the ions are present in the electrolytic solution or in electrolytic cell? Na plus ions are present, 2 Na plus ions are left, and 2 OH minus ions are left. Then converted into 2 NaOH, sodium hydroxide will form. So the electrolysis of aqueous NaCl at anode, the product is chlorine gas. At cathode, the product is hydrogen gas, and the electrolytic cell contains sodium hydroxide solution. That's why after electrolysis of NaCl, the resultant solution nature is basic nature. NaOH is formed. But NaCl is neutral. Before electrolysis, sodium chloride solution is neutral because NaCl is the salt of strong acid and strong base salt. But after electrolysis, what happens now? It forms NaOH. The resultant Na plus ions and OH minus, because Na plus ions cannot reduced at cathode, because when compare the discharge potential values or deposition values, H plus ions is more when compared that Na plus ions. So H plus ions can be deposited very easily when compared that Na plus ions, because Na plus ions having more discharge potential value. So the deposition order is inversely proportional to discharge potential values or discharge potential order. Okay, that you have to keep it in your mind for both cations and anions. That's why at anode chlorine gas is formed and cathode hydrogen gas is formed. See here, aqueous solution, then there is a compulsory two positive ions or two negative ions are forming. But molten NaCl we are using as electrolyte. Molten sodium chloride. Molten sodium chloride is present means there is no water. Molten state means semi-liquid. Molten state means semi-liquid. So solid state, in pure solid state they cannot act as electrolytes. But in molten state or in aqueous state, the substances acts as electrolytes. The substances acts as electrolytes. So molten NaCl is present, then the NaCl can be ionized to give Na plus Cl minus. There is no computation of any other cations and anion. There is no H plus and OH minus ions. Then immediately what happens now? At anode, the Cl minus ions can be oxidized to form Cl gas and releases two electrons. The two electrons formed at anode converted into cathode side, and at cathode what happens now? Two Na plus ions accept two electrons and deposit sodium metal at cathode. Okay, so molten NaCl on electrolysis, what are the products formed in cathode and anode? Anode chlorine gas and cathode sodium metal. But instead of molten NaCl, aqueous NaCl we used, means what happens, ma'am? They forms two positive ions and two negative ions are present. Along with Na plus and H plus ions also present. H plus ions discharge potential value is less. That's why H plus ions can be reduced very easily when compared that Na plus ions. Then they liberates hydrogen gas at cathode. That is very, very important, ma'am. See, like few examples. Electrolyte, electrodes, cathode and anode. So mostly I am using here inert electrodes, platinum only. Platinum and the platinum inert electrodes. Then products formed at anode and the cathode. Products formed at anode and the cathode. Let's see the first one. Aqueous NaCl I used. Then at anode chlorine forms, at cathode hydrogen, not Na plus ions. Next, the second one is K2SO4 I used, potassium sulfate. See, aqueous potassium sulfate I used. Aqueous potassium sulfate if I used means the potassium ions, K plus ions and SO4 2 minus ions, the positive and negative ions, they discharge potential K plus ions as well as SO4 2 minus ions, their discharge potential values are more when compared to H plus and OH minus ions. Then what happens, at anode, oxygen gas will liberate because the OH minus ions immediately oxidize to form O2 gas, oxygen gas, and H plus ions immediately reduce to liberate hydrogen gas. Okay. Aqueous copper sulfate. See, the copper sulfate we are used as electrolyte aqueous medium. Aqueous copper sulfate if I used as electrolyte, then what happens, Copper plus 2, its discharge potential is less when compared that H plus ions. When compared to that H plus ions, then immediately at cathode, copper metal only will deposited. But sulfate ions and OH minus ions, discharge potential values dP is more when compared to OH minus ions. Then the OH minus ions will be oxidized to liberate oxygen gas at anode. Okay. The fourth one is molten NaCl. If I use then chlorine gas will form at anode and sodium metal will be deposited at cathode. Then molten or fused MgCl are used. Molten or fused magnesium chloride are used. Then forms chlorine gas at anode and magnesium metal at cathode. But instead of aqueous MgCl if you are used, if aqueous MgCl if you are used, it means what happens, chlorine will liberate. Okay, because Cl minus ions deposition value is more when compared that OH minus ions. But Mg plus 2 and H plus ions. H plus ions can be deposited very easily when compared with the Mg plus 2. That's why hydrogen gas will liberate. So like observation.